Okay, so here is the test review. So the first topic is factoring. So factoring is a list of all the numbers that a given number can be divided by, and you have a integer or a whole number. I don't think we ever factor negative numbers, so it's going to be, yeah, actually the problem says find the natural number factor, so it's always a positive number. So I'll give you a number, and so let's pick something here like 80. So the factors of 80. Well, what you want to do is make sure you leave enough space so you can write them all out. And you start with 1 on the left-hand side and the number on the right-hand side. And then you just go to subsequent higher numbers, and you only have to go as far as whatever the square root of 80 is, which close to the square root of 80, which is 9 times 9 is 81. So once you get to 8, you're done. So what's the next number after 1? 2, divide 80 by 2, and you get 40. And you can use your calculator for this. Then you think about 3. Remember, you can't divide, if these added together are not divisible by 3, then you can't divide by 3. So 8 plus 0 is 8, which is not divisible by 3. Those 3 is not going to work. 4 will work. So you take 80, divide by 4, get 20. 5, you can divide it by 5 because it ends in a 0. So you have 5. 80 divided by 5 is, I'm just going to use my calculator, I think 16. 80 divided by 5 is 16. Okay, 7, 6, you can't divide by 6 because you couldn't divide by 3. 7, you can't divide by 7. 8, oh yeah, of course you can divide by 8. So you get 8 and 10, and there's your list. So I've got 2 problems, 2 things you have to factor. Just make sure you leave enough room. The second problem has to do with the divisibility test, and I've already used it. So I'm just going to give a couple numbers. You're going to have to tell me whether it's divisible by which numbers. And the most important one, 2 is easy because it's even. It's divisible by 2. It ends in 0, 2, 4, 6, 8. The most useful one is 3 and 5. 5 is good too because you can take a number and divide by 3. If you divide it by 2, you can do that because it's even. So 6 always works out ultimately anyway. So let's say I give you number 5,720. Let me see here what I'm going to pick. 24. So what you want to do is you want to add the numbers together. So show me you're adding them together. You'll get the answer, which is 18 in this case. And then you'll say since 18 is divisible by 3, 5,724 is also. Okay, so you could say yes, it's divisible. This is the reason. This is the logic. Let's say I pick a longer number. 1, 3, 4, 7, 2, and I'm going to pick something that doesn't work out. So 8, 15, 17. Okay, put the 2 there. So it's 6 digits. So again, I mean, you can find out by plugging your calculator, but that is not the purpose. You're going to have to show this whole thing written out. And if you add these together, if I did my math right, that's 4, 8, 15, 19. Since 19 is not divisible by 3, neither is 134,722. Now I'm going to ask you to do prime factorization. Well, actually, no, that's the greatest common factor. So before we get to that, first in section 1 is prime factorization. So it's kind of like factorization, except we're going to list the prime numbers that I can multiply together to get some given number. So there's really two ways, just using a tree and using a list. So unless you have something against doing the list, I'd say use the list. So let's say 240. What's the prime factorization of 240? So you list that, you draw this little bracket, you start dividing it by 2 until you run out of even numbers. So I can do that 4 times. This divided by 2 is that, this divided by 2 is that, this divided by 2 is that, this divided by 2 is that. I've done it 4 times. This is now not even. So then I go to the next larger prime number, which is 3, and 15 is divisible by 3, and you end up with 5. And so now we just got all prime numbers. So what I want you to do, besides doing the list, is to write it out in exponential form. So we can list all the numbers that were used in the factorization and then count up the number of times we had it. So we have 1, 2, 3, 4, 4 2s, so we have 2 to the 4th. We have 1, 3, 1, 5. Okay, so I've got 2 problems like that, but I'm just going to show you the one because it's basically the same process. Okay, now we're going to go to the greatest common factor, and there are 3 ways that you need to know how to do this. And I'm going to call them, there's one called the prime factors method. So we basically do the prime factorization of each one separately. So this is greatest common factor. So let's pick 64 and 80. So we do these separately, prime factors method separately. So we divide by 2. Until we run out of choices here. But maybe not have been a great choice to demonstrate this. But turns out 64 is just equal to 2 raised to the 6th power. 2 times 2 times 2 times 2 times 2 times 2. Okay, 80 divided by 2 here, it's even. Divided by 2, it's even. Divided by 2, it's even. Divide by 2, yeah, we're done. Okay, so 80 is 2 to the 4th times 5. So the prime factors method is you list all the prime factors that are in both of these. In this case, the only one that's in both of them is 2. And then you list the least exponent of the 2 cases. So I have 2 to the 6th, I have 2 to the 4th. So I get 2 to the 4th, which is 2 times 2 times 2 times 2, which is 16. Because you might have thought 8 was the answer, just because you might have said, oh, 64 divided by 8 is, but there's 16 times 5 is 80, and 16 times 4 is 64. So it's actually 16. So again, this is exactly what you need to do. Do the prime factorizations, show the factorization in this form, look to see which number is common between the 2. In this case, it's only 2. Use the least exponent. So, just because I picked this, if I'd gotten something like 2 cubed times 3 times 5 in one of them, and I had 2 squared times 3 squared times 5 squared. So those are the two numbers. Let me just multiply them out. So we have 8 times 3 times 5. 8 times 3 times 5. So this is 120. So if you did the prime factorization of 120, you get that. 4 times 9 times 5, that's 180. So let's say these were the two prime factorizations. I started with 20 and 180. The greatest common factor would be which numbers do I have in common? Well, actually all of them. I have a 2 to the third, 2 to the second. I have 3 to the second, so I write that down. I have 5 to the first, 5 to the second. Actually, I don't think I multiplied that out right. This one is not 180, it's bigger. It's 4 times 9 times 25, which is 900. Okay, so that's 900. Okay, so we have 2, 3, and 5. This is raised to the third power, this is raised to the second power, so I take the smaller of the two. This is raised to the first power, this is raised to the second power, so I do the first power. This is raised to the first power, this is raised to the second power, so I do it to the first power. So I'll get 2 squared, which is 4, times 3, times 5, and I get 60 as the greatest common factor. You can see 120 divided by 60 is 2, 900 divided by 60 is 15. So that makes sense. Okay, so that's the prime factors method. Let's do a case where we're going to use the other method, and you can use this with 2 numbers or 3 numbers, and it's called the dividing by prime factors method. So they might sound almost the same, but it's dividing what did I call it? Dividing by, or dividing by prime factors method. So what's the difference between what we call these? Dividing by prime factors method. The other one's prime factors method. So it's the dividing thing. This thing that characterizes it. So let's pick 3 numbers in this case. Let's say 120. 80 and 64. Okay, so those are the 3 numbers. So the dividing by prime factors method is you do them all at one time. This is for greatest common factor. So you look at these 3 numbers and say, is there a number I can divide all these by? Well, since they're all even, I'm just going to start there, 2, and then you divide every one of them. Then you go to see if you can divide them all by 2 again, which I can, because they're all even. So I get 30, 20, and 16. Okay. Can I divide them by 2 again? Yes. 15, 10, 8. Now, can I divide all these by 2? No. Can I divide them all by 3? No. Can I divide them all? So it's all, you've got to divide all of them. And there really is, these can both be divisible by 5, but this one's not. These can be divisible by 2, but that can't. This can be divisible by 3, but these both can't. So that's all I have. And all you do is you take the right of this whatever's here. And so I get that the greatest common factor is equal to 8, which is 2 times 2 times 2. And again, you can always go back and check by dividing each one of these by this number just to check it. So you take 120 divided by 8, you would get 15. 80 divided by 8 is 10, and 64 divided by 8 is 8. So these are these numbers down at the bottom. So these are actually what's left over when you divide it by that same number. So that's the dividing by prime factors method. The last case is this is the Euler's method. So we can only do this with two numbers. So let's take 60 and 220. So it looks like 20 is the answer, but let's just use the Euler's method. Hopefully it'll work out where there's a few steps. So you take the smaller number, the larger number divided by the smaller number. You see how many full times you can divide that in, and the answer is 3, which is 3 times 60 is 180. You subtract this, you'll get 40. Okay, then you take this number, this bigger number, 60, and divide by 40. So 60 divided by 40, you can do that one full time with the remainder of 20. We're trying to get to a zero remainder. You keep repeating this until you get to a zero remainder. So we take 40 divided by 20. That goes a full 2 times into 40 with a zero remainder. So that's when we stop. That's not the answer. The answer is this number previously, and it is 20. So again, you could look at this, and 60 divided by 20 is 3. 20 divided by 20 is 11. Those are both prime numbers. So okay, so then you've got least common multiple. You've got the only two methods here. Well, there's a third method. I've forgotten about that, but I'm going to only ask you about 2 of them. Again, there's the prime factors method, and there's the dividing by prime factors method. If you have any confusion about which one to use, ask me. I'll guide you a little bit. Okay, prime factors method. So let's see. Well, why don't we do these same 2 numbers we had over here? Here we're finding the greatest common factor. So the prime factors method for the lowest common multiple is you do them separately again. You do the prime factorization of these 2 numbers separately. So we divide by 2 until we get an odd number. Okay, then we go to the next prime number, which is 3. 3 divided by 15 divided by 3 is 5. So we're done. 60 equals 2 squared times 3 times 5. 220 divided by 2 is 110. 110 divided by 2 is 55. That's odd. It's also not divisible by 3, so we get a 5, 5. 55 divided by 5 is 11. Okay, so that is the prime factorization. Now, the lowest common multiple, what we do is we look at, let me write that out. So 220 is equal to 2 squared times 5 times 11. So the least common multiple is greater than each one of these. So we're going to choose all of the numbers that are in any of the factorizations. So we have a 2, we have a 3, we have a 5, we have 11. And then we pick the highest multiple of each one of these. Well, we've got 2 to the second, 2 to the second. Well, 2 to the second is the highest. I have 3 to the first and 3 not in there. So 3 to the first, I've got 5 to the first, and I've got 11 to the first. So we just multiply all those things together. And so we have 2 squared, which is 4, times 3, times 5, times 11. It's 660. So it's the least common multiple. And so 60 times 11 is just thinking about something. Okay, we'll come back to this. Okay, so 60 times 11 is 660. So this 660 is the 11th multiple. And 220 times 3 is the, so it's the third multiple of 660. Okay, so that's the prime factors method. Now if you have, again, you can do this with 2 or 3. You can do the other one, which is the multiply or dividing prime factors method, not multiplying, dividing. So I'm giving you each one of these by prime factors. Actually, prime factors. Let me just erase that. Dividing by prime factors method. Okay. So let me pick something here. 30, 48, and 100. Okay, so the dividing by prime factors method, again, you do all of them at one time. You look for a common factor between all 3 to start with. So I see that they're all even, so I can divide them by 2. I get 15, 24, and 50. Okay, is there another number I can divide all 3 by? I can divide this one by 3, I can divide that one by 3, but I can't divide that by 3. So 3 is not going to work. I can divide this one by 5, but not this one, but I can this one. 6, I can divide this by 6, but I can't do either one of those. So it looks like 5 or 3. I'll use 3. So we have 3. So when you have not all of them you can divide by 3, you divide the ones you can by 3. 15 divided by 3 is 5. 24 divided by 3 is 8. If you can't divide it, you just copy it down in the next column, the next row. Okay. Now, we do it again. Can we divide both of these by 3? Okay, so can't divide any of them by 3. You can divide these both by 2. So let's go ahead and do that. Oh, I shouldn't be able, oh yeah, it's fine. I could have divided these both by 2 up here, but one step at a time. So divide these 2 by 2. So the one I cannot divide by 2 is this one, so just copy it down. 8 you can divide by 2, and 50 you can divide by 2. Okay, next, can I divide these 2 out of the 3 by a common term? Well, I can't divide them by 3. I can divide these 2 by 5, so why don't we do that? So the one I can't divide by 5, I just copy down, unchanged. 5 divided by 5 is 1. 25 divided by 5 is 5. And I come to this point, and now there's no common factor except 1. So for the greatest common multiple, you take all that's in the column here and everything that's left on the bottom row. So you multiply that, so the least common multiple is 2 times 3 times 2 times 5 times 1 times 4 times 5. 2 times 3 times, I'll just put them in my calculator, 5 times 1 times 4 times 5, and I get 1,200. And again, you can, well actually, no, it doesn't count. You can't use any of these numbers to predict what it's going. But if I take 1,200 divided by 30, I get 40 up here. If I take 1,200 divided by 48, I get 25. If I take 1,200 divided by 100, I get 12. So these two can be divisible by 5, but this one can't. These two are divisible by 2, but that one isn't. These two are, okay, we did 5, we did 2. What else is there? 3, but none of them could be divisible by 3. So that's pretty much it. So that works out. So it's 1,200. Okay, so those are the methods for greatest common factor, least common multiple. So that's pretty much it for that. Then we have the Fibonacci sequence. So all I'm asking you to do is I'm going to give you, I'll give you two terms. You have to calculate the next one. So, if I start from the beginning, I have 0 plus 1 is 1. 1 plus 1 is 2. So let's put little commas in here. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. 13 plus 21 is 44. 34. So I might say if the 1, 2, 3, 4, 5, 6, 7, 8, 9, if the ninth term is 21 and the 10th term is 34, what are the 11th and 12th terms? Question mark. So all you have to do is you'd say the ninth term equals 21 plus 34, which is 55, and the 10th term is 34 plus 55, because that's the last two, which would be 89. Okay, so that's what I'm looking for you to be able to do. Negatives. What I'm looking for here is if you're multiplying a lot of numbers together, and I want you to give me the answer, and I know you can multiply it in your calculator, but it's a pain in the butt to write all these negatives down. So it's easier just to multiply the positive numbers together, positive parts of it. And so if I said, what's the answer to that? What you would do is you multiply all the numbers, 2 times 5 times 8 times 7 times 1 times 7, and that would give you 3,920. And then you would just count the number of negative signs you have. 1, 2, 3, 4. So since the number of negatives is even, the answer is positive. So I put positive, or I just leave it the same because it's already positive. So, instead of having to do negative 2 times 5 times negative 8 times all that kind of stuff, it's just much easier to do 2 times 5 times 8 times 7 times 1 times 7. If I did, let me just check, make sure I did that right. 2 times 5 times 8 times 7 times 7, 3920. And then I go 1, 2, 3, 4, even, boom. So the other case, say we have things where you're dividing things out. I'll give you one that ends up being a whole number here, so I'm not sure what this is going to be because I didn't do it. It may be a fraction, it may be a decimal. But again, what I would do is I would take 2 times 1 times 7 times 3 divided by 6 divided by 1 divided by 3. Just use all the positive numbers. It turns out to be 2.33. And then I would count 1, 2, 3, 4, 5. And I put a negative, since it doesn't matter where they are in the numerator or the denominator. You just count up the number of negatives in the total expression. Since the number of negatives is odd, the answer is negative. Because it'd be easy to plug these in your calculator and forget one of them. You got all those negative signs to worry about, so it's just easier. Multiply the numbers together and then just count. Less chance for error. And then finally, we've got we had rational numbers. So we just did that today or yesterday, depending upon which class it's in. So I'm not going to go through all the examples, but basically what I'm doing, you're going to say add well, I will go through it. Okay, so let's say you're adding two fractions. Again, rather than finding a common denominator, what I'm looking for you to do is to cross multiply these together, and because they're both positive, they're added together in the numerator. So you take 3 times 14 plus 5 times, and then you multiply the two denominators together. Okay, so at that point you can go ahead and just multiply, do the numerator and then the denominator separately. So don't do anything yet. So we're going to take 4 times, make sure I do that right, 3 times 14 plus 5 times 7. That gives you 77. And then in the denominator we have 7 times 14, which is 98. Okay, so that's the basic result, but then we want to see if we can simplify it. So you do it in steps, just like we did the factorizations. You look to see whether you can divide them both by 2, which I can't, because this one's odd. I can't divide it by 3, because this adds to 17, this adds to 14. They're not divisible by 5, but they are divisible by 7, so you have to keep going. 77 divided by 7 is 11, and I know that this is divisible by 7 because I multiplied it by 7, so it's 11/14. Now if you have a negative, if you had 7/16 minus 5/32, you take the positive numerator multiplied by the denominator of the negative part. And then you subtract the negative numerator times the other one. So you cross multiply and then you do 16 times 32. So then plug those into your calculator, not the whole thing, but just the numerator, and I'll get 144 over 512. And then we simplify. So divide by 2. Divide by 2 again. Again, I'm doing it in my head, but you can use your calculator. Keep going until you run out of even stuff. So that's 64, 9 over 32. So it's 9/32 is the answer. Multiplication. Simply just multiply the numerators together, the denominators together. Again, look to see whether you can simplify it. In this case, you can't, because these are not divisible by 2 both. You can't divide them by 3 both, and this is divisible by 3 times 7. You can't. So this actually you don't have to simplify, but you always have to look that out. As far as division is concerned, I've got a couple of these because that's the one that's more difficult. So if you have, say, 7/9 divided by 6/5, we always rewrite that as the reciprocal of that. We multiply, instead of dividing by that rational number, we multiply by the reciprocal. So we'll get 45 over 54. No, 35 over 54. And again, look to see whether you can simplify those, which I don't think you can, because this is divisible by 3, but that's not. This is divisible by 2, but that's not. This is divisible by 5, but that's not. This is divisible by 7, but that's not. So that's pretty much it. We're done. Again, you have to, and also there's going to be one of these more complicated fractions where you have a numerator that has addition or subtraction. And let's say we have 2/3 plus 3/32. Okay, question is what's the answer? So we use these techniques that we've just done in both the numerator and the denominator separately. So here we're going to take 7 times 3 minus 1 times 8 divided by 3 times 8. And then we divide the whole thing by 2 times 32, 2 times 32 plus 3 times 3, all divided by 3 times 32. So these are multiplied together. These are cross-multiplied and added. So let's go ahead and do the 21. We have 21 minus 8, which is 13. So the first numerator is 13. Denominator is 24, 3 times 8. Then we divide by 2 times 32 plus 3 times 3, which is 73, divided by 3 times 32, which is 96. Okay, once we've finished all these, and we've just got the two fractions, then we do change the division to multiplication by doing that. Now, assuming that I don't recognize that this is 96 over 24 is 4, and use that, we're just going to multiply the whole thing out. So you take 96 times 13. I'm just multiplying rational numbers together, which means I multiply the numerators together, and I multiply the denominators together. So I get 1,248 divided by 1,752. Okay, so it doesn't look like we can divide by 5s or 10s because we've got these numbers in the end. So we'll just keep dividing by 2 until we run out of that, and then we'll see about 3s, if that happens or not. So again, use your calculator. You should have enough time. So this is 624 over, so I am using my calculator just to show you that you can do it. Okay, I'm going to revert back to my brain now. So this is 312 and this is 437. Is that right? 874 divided by 437. Well, no, that's what I'm doing. Taking 874 divided by 2, 437. Okay. They're not even. So we're going to have to see if we can do 3. 312, you can divide that by 3, but you can't divide that by 3 because you get 14. Yeah, I think that's about as far as we can go. You know, we could try 312 divided by 7. 312 divided by 7. That doesn't work. 312 divided by 11. That doesn't work. 312 divided by 13. That's 24. So 312 you can divide by 13, but 437 divided by 13, you can't do that. So 13 works on one, but it doesn't work on the other. And ultimately what you can see here is you've got, this is 96 divided by 24 is, it seems like something's wrong, so let's use it. So 96 divided by 24 is 4, so we'd have 13 times 4 divided by 73. So we can reduce this further, so there must be something. 13 times 4 is 52, so we get 52 over 73. So what is that number? To to go from, let's see, so 312 divided by 52 is, nope, 312 divided by 52 is 6. Did I make a mistake somewhere in my calculations here? 312 and 437 divided by 6. I can't divide it by 6, it's odd. Okay, so let me see, what did I do wrong here? 24 times 73 is 15, okay, divided by 2, 876. Oh, that's my problem right here. 876, I made a mistake there. Okay, so it is divisible by 2 again. 876 divided by 2 is 438. And then 312, now I don't trust myself, 312 divided by 2 is 156 over 219. You can divide this by 3, and you can divide that by 3. So 156 divided by 3 is 52, and 219 divided by 3 is 73. So that's the final answer right there. Okay, and then the last thing we just talked about that just briefly is converting from decimals, terminating decimals to fractions. So if I do 0.36, because that has 2 decimals, I'm going to multiply by 100 and divide by 100, which has 2 zeros. I get 36 over 100, and then I simplify that. So I do the same thing I was just doing here. Divide by 2, I'll get 18 over 50. Divide by 2, I get 9 over 25. I plug that in my calculator. 9 divided by 25, I get 0.36. So there's no reason you should ever get these wrong. You just have to make sure you include all the steps. Okay, then you have, let's do a 3-digit one. I've got 2 2-digit ones and 2 3-digit ones. So let's say it's 748.748. There are 3 digits, so I multiply with 3 zeros, which is 1,000. So I get 748 over 1,000. So we divide by 2. 748 divided by 2 is 374 over 500. Okay, the row still. So divide by 2 again. 187 divided by 250. That might be as far as we can go. Can't divide by 2, can't divide by 3, can't divide by 5. I don't think you can divide by 7. 187 divided by 7 is not a whole number, so that doesn't work. 7, next prime number is 11. 187 divided by 11. I'm 99% sure that now you can divide 187 by 11, but you can't divide 250 by 11. So you could also do a prime factorization and then simplify it. But anyway, that seems to be the final answer. Again, plug it in your calculator, and I get 0.748. So that's pretty much it. So factoring, using divisibility tests, doing prime factorization, greatest common factor using 3 methods, least common multiple using 2 methods, knowing how to generate the terms of a Fibonacci sequence, how to deal with how many negatives are in a sequence of multiplications to find what the answer is, adding, subtracting, multiplying, dividing fractions, converting decimals to fractions. That's it. So hopefully you guys will do well. It took me about 16 minutes to take the test. But since it's pretty straightforward, I think you'll be okay. If somebody needs a little extra time, I'll let you go. In Rockbridge, you can go to the testing center, and at in Covington or Clifton Forge, and I'll let you go to the library. So don't worry about time. Okay, I can stop now.